This question is from GATE 2015, Mechanical Engineering paper, set 3, question number 48. A cantilever bracket is bolted to a column using 3 M12 by 1.75 bolts P, Q and R. The value of maximum shear stress developed in the bolt P in megapascal is dash. Let's have a look at the figure and see how it will be solved. Now in this figure, we can see an eccentric load 9 kN acting at some other point away from the bolts. So definitely this load has to be transferred on the bolts. So when it will be transferred on the bolts, it's not physically transferred, we are transferring it for the analysis purpose. So in order to transfer this 9 kN at the centroid of these bolts, we will have to apply a 9 kN direct force, and along with that, a moment will be acting, that is 9 into 250 millimeters. So it will be a moment about this point Q, because it's the centroid of these bolts, that is of 9 by 250 kilonewton millimeters. Let's draw it here again. We have 3 bolts, one as at Q itself, one is at a distance 30 millimeters from Q, and another one is at a distance of again 30 millimeters on the other side. Name these as P and R. And this system will look something like this. Now this load that is coming, we can distribute it into these 3 bolts. The direct load can be distributed directly. We have to find the shear stress on P. So let loads on P be one due to the direct shear, that is PD, and another due to the torque, that is PT. Both will have a nature of shear stress only because the cross section of the bolt is being applied a tangential force. And that is why both of them are shear forces, one due to direct shear and another due to the torque. And then finally, force on bolt P, which we have assumed to be P itself, can be found out using the resultant of the two. Now how that will be found out? So on P, we have one direct force, that is 9 kilonewton divided by 3. 9 by 3 kilonewton, which is 3 kilonewton. So right away we found out PD. PD is 3 kilonewton. We have to find out PT. And first we'll find out the direction. This torque can be transferred on the bolts in the form of shear forces in such a way that the pair of shear forces should form this torque. Okay. Torque here is 9 kilonewton by 250 millimeters. So the unit of this torque will be kilonewton millimeters. Let this torque be as it is. Q will not be subjected to any shear force due to torque because it is situated exactly at the centroid of the bolts. The force that will act on P, which can produce this torque, will be like this towards the right, because we need to form a torque of clockwise, and on R it will be towards the negative direction. So these forces on R and P will in turn produce a torque of this same magnitude. We have to find out these unknown forces. So this one will be PT and this one will be RT. Both will be equal to each other. They will form a couple. P and R are equidistant from Q. So to find out these forces, PT equal to RT, we can use the torque 9 into 250 divided by distance between RT and PT, which is of 60 millimeters. So we'll divide this by 60 millimeters. So PT is equal to 75 by 2, which is 37.5 kilonewton. Now we have got PT and PD. Angle between them is 90 degrees. So the resultant can be calculated now. Resultant force P is equal to root over PD square plus PT square plus 2 PD PT cos of theta between them. Theta is 90 degrees, cos 90 is 0. This term becomes 0. So therefore P is equal to, let's just put the values that we have found out. Of PD it is 3 kilonewton and for PT it is 37.5 kilonewton. So 3 square plus 37.5. Therefore 3 square plus 37.5 square, which is nothing but 37.62 kilonewton. So this is the resultant shear on the bolt P. We have to find out the shear stress on bolt P. Let that be tau P. Shear stress is nothing but resistive force P divided by the area that is resisting the shear or shear area of the bolt. So shear area of the bolt can be found out using the diameter given. Diameter is given in the specification of bolts, that is M12. M12 means diameter is 12 millimeters. So if we substitute, this is in kilonewton, let's convert it to Newton. 37.62 into 10 to the power 3 divided by pi by 4 into 12 square, which is equal to 332.63 Newton per millimeter square. Area is in millimeter square, which is almost equal to 333 Newton per millimeter square. Newton per millimeter square is equivalent to megapascal. Let's fill in the answer. So the value of maximum shear stress developed in the bolt in megapascal is 333 megapascal. 332.63, not a problem. To learn more about eccentric connections, you can refer to the NPTEL video, Module 3, Lecture 1, Eccentric Connections, Rivet Joints, from the course lecture series on design of steel structures. It is by Dr. Damodar Maiti. He is from Department of Civil Engineering, IIT Guwahati. I hope the solution will help you clear your doubt. Thank you.